This is a third question set on square root. Let us go ahead with our first question. Under root 7 plus under root 5 the whole divided by under root 7 minus under root 5. Let us multiply the numerator as well as the denominator by under root 7 plus 5 so that we get rid of the square roots on the denominator. So let us do that. This is equal to under root 7 plus under root 5 upon root 7 minus root 5 multiplied by, we are multiplying the denominator and the numerator by root 7 plus root 5. So in the denominator we have root 7 minus root 5 multiplied by root 7 plus root 5, something similar to a plus b times a minus b. So on the denominator we can have a square minus b square, which is the formula of a plus b times a minus b, under root 7 square minus under root 5 square. So we are taking the square of the square root, so we can get rid of the square root. So we can directly write 7 minus 5. And in the numerator we have a plus b times a plus b. So a plus b whole square. Let us write it, root 7 plus root 5 whole square. So this is equal to a plus b the whole square is equal to a square plus twice ab plus b square. So we have root 7 square, which is nothing but 7, plus twice ab, so 2 times root 7 root 5 plus b square under root of 5 the whole square, so which is 5, upon 7 minus 5 is 2. This is equal to 7 plus 5 is 12 plus 2 root, we can take the complete root of 7 times 5. So 7 times 5 is 35 divided by 2, and this is equal to 12 by 2 plus 2 root 35 by 2. This 2 gets cancelled. 2 times 6 is 12. So the answer is 6 plus root 35. Let us move on to question number 2. It was asked in the CBI exam of 2003. So you have been given the value of root 2 and you have to find out the square root of this expression. Well, let us simplify this expression. Root 2 minus 1 upon root 2 plus 1. The aim is to get rid of the denominator. So how can we do that? Well, if we multiply the numerator and the denominator with root 2 minus 1, we can get rid of the denominator. Let's see how it goes. So under root 2 minus 1 times under root 2 minus 1 divided by root 2 plus 1 times under root 2 minus 1. We've multiplied the numerator and the denominator by root 2 minus 1. So this is equal to root 2 minus 1 times root 2 minus 1 is root 2 minus 1 whole square divided by, in the denominator you have a plus, there should be a 1 here. You have a pattern like a plus b times a minus b. So a plus b times a minus b is equal to a square minus b square. So you have under root 2 square minus 1 square. Let us keep the numerator as it is, root 2 minus 1 whole square divided by, in the denominator you have 2 minus 1, which is 1. So this value is simplified to root 2 minus 1 whole square. But you haven't been asked this value. You have to take the square root of this value. So on the left hand side of equal to, you right now have root 2 minus 1 upon root 2 plus 1. Now take the square root of both the sides. So you have taken the square root of both the sides. Well, square root of a square is the number itself. So square root of root 2 minus 1 whole square is equal to root 2 minus 1. Now root 2's value has been given to you, which is 1.414. So it is equal to 1.414 minus 1, and it is equal to 0.414. So you have your answer, 0.414. Moving on to question number 3. You have to find the smallest number by which this number 5808 should be multiplied. so that the product becomes a perfect square? Well, first let us express this number 5808 as a product of prime factors. So let us find the prime factors of 5808. So 5808, when it is divided by 2, you get 2904. When again it is divided by 2, you get 1452. Again divided by 2, you get 726. Again dividing it by 2, you will get 363. 363 can be divided by 3. So you get the answer as 121. And 121 can be divided by 11. So 11 times 11 is 121. So let us express 5808 as a product of prime factors. 5808 is equal to 2 times 2 times 2 times 2, 1, 2, 3, 4 2's are there, times 3 times 11 times 11. If we group these numbers into squares, so we have 2 square multiplied by 2 square multiplied by 11 square, and 3 remains as it is. So it is 2 square times 2 square times 11 square times 3. So if we take the square root of 5808, you can find out 2 square and 2 square and 11 square, but 3 is not a perfect square. To make this a perfect square, let us multiply this by 3. If you multiply this whole number by 3, you get 3 square, and 3 square is a perfect square. So the number that this number 5808 should be multiplied with so that the product becomes a perfect square is 3. Question number 4. You have to find out the greatest 4-digit perfect square. Well, if you take the square of 100, you get 10,000, which is a 5-digit number. So the greatest 4-digit perfect square must be less than 100. So let us take the square of 99. And if you take the square of 99, you will get 9801. Hence, the greatest 4-digit perfect square is 9801. And finally, the 5th question. What is the value of x square plus y square if the values of x and y are given? Let us first simplify x and y by getting rid of their denominators. So we can write x as equal to root 3 plus 1 upon root 3 minus 1. I'll multiply the denominator and the numerator by root 3 plus 1. So times root 3 plus 1 upon root 3 plus 1. So this is root 3 minus 1 into root 3 plus 1. That is a minus b into a plus b, which is a square minus b square. So in the denominator I have root 3 square, which is 3, minus b square, which is 1 square, which is 1. So 3 minus 1. In the numerator I have root 3 plus 1 whole square. Right. Let us simplify y. Here we'll multiply the numerator and denominator by root 3 minus 1. So y is equal to root 3 minus 1 times root 3 minus 1 upon root 3 plus 1 times root 3 minus 1. So the denominator will be root 3 whole square minus 1 square. A square minus b square, which is 3 minus 1. In the numerator you get root 3 minus 1 whole square. So you have the simplified values of x and y. X is root 3 plus 1 whole square by 2, and y is root 3 minus 1 whole square by 2. Well, let us actually simplify this more. You can solve root 3 plus 1 whole square, which is a square plus twice ab plus b square. So a square, that is root 3 whole square, is 3 plus twice root 3 into 1 plus 1 by 2, which is 4 plus 2 root 3 by 2. Again, you can get this as 4 by 2 plus 2 root 3 by 2, which is 2 plus root 3. So x's value is 2 plus root 3. Let us write it. X is equal to 2 plus root 3. Now you can also simplify y. This is root 3 minus 1 whole square. So a minus b whole square, which is a square, that is root 3 square, so 3, minus twice AB, so minus 2 root 3 times 1 plus B square, that is 1 square, which is 1 upon 2. This is equal to 4 minus 2 root 3 by 2. This is equal to 4 by 2 is 2 minus 2 root 3 by 2 is root 3. Therefore, y's value is 2 minus root 3. So y is equal to 2 minus root 3. Now you have to put the values of x and y into x square plus y square and get the final answer. Let's do that. So you have x square plus y square. So 2 plus root 3 whole square plus 2 minus root 3 whole square. So it is equal to a plus b whole square is a square, that is 2 square, which is 4, plus twice ab. So 2 times 2 is 4 times root 3. So 4 root 3 plus b square, which is root 3 square, which is 3. Plus, now you have to simplify this term. So 2 square, which is 4, minus twice ab. So 2 times 2 is 4 times root 3. 4 root 3 plus b square, root 3 square, which is 3. So 4 root 3 and 4 root 3 gets cancelled out. What remains is 4 plus 3 plus 4 plus 3, which is 4 plus 4 is 8, plus 3 is 11, plus 3 is 14. So the answer is 14.